Hi, data analysis. I got a joke for you today. Why did the toilet paper cross the road? Because it was stuck in a crack. Oh man, that comes from Mrs. Zortman's daughter. So you can thank her for that one. Today, we were going to go into confidence intervals, but we're going to be able to do infinite geometric series. I was looking at our final schedule. I think we'll be able to fit this in. It's really cool, straightforward, easy. Let me kind of show you what happens here. So, number one, let's go with a series that looks like this. 2 plus, let's multiply that by 3, 6, multiply that by 3, 18, multiply that by 3, 54, and so on and so forth, right? And if I said to you, let's just add up all those numbers forever, you would say, well, Mr. Manor, that if I added those up forever, that would be infinity. That would get infinitely large and never stop growing. And that is absolutely correct. We call that diverge or divergent when that happens. Okay? So you could say diverge or it's divergent. When a series, geometric, multiplying by 3, goes up and you can never stop adding, right? But there are some weird cases where when it goes smaller like this, and basically I'm dividing by 2 here, or say multiplying by 1/2, that it doesn't go to infinity, right? Because it's getting smaller and smaller and smaller, and actually it's going to converge. All right, and when it's going to converge, this R value, or what you're multiplying by, 28 times 1/2 equals 14, 14 times 1/2 equals 7. If that R value, okay, is less than 1 and greater than -1, so basically if it's a fraction, 1/4, 1/3, we're going to converge, and we can actually find what that sum is. All right, so let's go through a few examples of converge and diverge again, and then I'll give you the formula for how to figure out those sums when they actually do converge. All right, so let's say I have a first term of 4 and an R value of 3. All right, is this going to converge or diverge? Well, I could list it and look. 4 times 3 plus 12 times 3 plus 36. And as you can see, if I added those forever, that would diverge. Clearly, get bigger and bigger and bigger and bigger. However, if I had a first term of 8 and an R value of 1/2, 8 plus 4 plus 2 plus 1 plus 1/2, this number is going to get all the way small, really close to 0. And that's going to be convergent. And I'll show you how to find what that adds up to here in a couple of minutes. Okay, so basically if this R value is not in here, it's going to diverge. And if that R value is in there, it's going to converge. Let me show you what happens to converge and how do we find that sum. So how do we find sum when it's convergent? All right, so that's our next question. How do we find the sum when it converges? Well, yesterday I taught you to take the first term, multiply by 1 minus r to the number of terms over 1 minus r. So that was what I told you to do. And we're going to use that formula to figure out what happens when there's an infinitely many terms. Those terms keep going forever and ever and ever, keep adding, adding, adding. Okay, so let's do that. So the first term, 1 minus, now this r value, okay, is still going to be there. The number of terms is infinity. Right, so I get an infinitely many number of terms. First term from yesterday, 1 minus. Now, anything to the infinity power, other than some rare occasions, anything is going to be 0, because as this power got bigger and bigger and bigger, and bigger, it's going to become 0, right? So for now, just trust that that's 0. I know there's some weird cases where that doesn't happen. So basically, I take the first term, multiplied by 1 over 1 minus r. Okay, that is my formula for finding the sum of a convergent infinite geometric series. Let me make the formula a little bit better. First term over 1 minus r. So that's all you do, first term over 1 minus r, because I can just take that first term and multiply by the 1 and put it up on top. This is my formula. First term over 1 minus r will give me the sum of an infinite geometric series. All right, so let's go back to this problem right here. First term's 8, r is 1/2. Let's find what that would add up to if I added and added and added forever. So let me write that down. First term is 8, a sub 1 equals 8. Our value is 1/2. Let's use our handy formula. The sum of an infinite geometric series is a sub 1, which is my first term, over 1 minus r. So first term, it says, is 8, 1 minus 1/2. 8 over 1/2, 16. Basically, if I added 8 plus 4 plus 2 plus 1 plus 1/2, I kept going, I'm going to get to 16. That's as far as I'm going to go. Not any farther, but I'm going to make it all the way to 16. So the sum of an infinite geometric series is you're going to use this formula to do it. Let's do a couple more examples. Let's say we go from x equals 1 to infinity of -4 to the x minus 1 power. You're going to see a problem like this on the homework, and you're going to give it a try. This problem is a trick because the r value is this base down here, right? Let's start listing the terms and see what it look like. If I put a 1 in here, that'd be my first term. 1 minus 1 is 0. -4 to the 0 is 1. Plus, put a 2 in here. 2 minus 1 is 1. -4 to the first power is -4. Plus, and what would happen here is these numbers would keep getting bigger. If I put a 3 in here, I'd get 16. They're going to keep getting bigger and bigger and bigger. Don't worry about the negatives. If this value is not between, remember this? If it's not in between there, it's going to diverge, which means this problem, there is no sum. So there's going to be a couple tricky problems on this worksheet. If that base is greater than 1 and less than -1, immediately you say, I can't find the sum, Mr. Manner. You're tricking me here, okay? So if you see that happen, no sum. However, if you see something that looks like this, actually let's use the letter K, because on the worksheet I used the letter K a couple times, and it looks like this. 36 times 1/3 to the k minus 1. So this one says to add up the first 36 terms. I'm sorry, it says to add up all the terms, right? Well, this base here on the exponent is a number between 1 and -1. So this one's going to converge, and we got to find its sum, right? If I wanted to list the numbers out, I could put a 1 in here, right? If I put a 1 here, that's a 0, making this be a 1. So my first term is 36, and then I'm going to divide by 3. I'm going to divide by 3 again. And I'm going to keep right on going forever. I want to add that up. So basically that's what I'm doing right there. But all I have to use is the formula. So when this number is between -1 and 1, here's my formula. The sum equals the first term. So my first term is 36. And to get your first term, take 1, put it in here. 1 minus 1 is 0. 1/3 of the 0 power, this whole thing becomes 1. Anything with the 0 power is 1. So 1 times 36 is 36 over 1 minus the common ratio. The common ratio is always this base here, 1/3. So if I add up all these numbers, I got 36 divided by 2/3, right? And I can use my calculator if I want. So I can go 36 divided by, don't forget your parentheses, 36 divided by 2/3. It's going to tell me 54. Okay, so if I add up all those numbers, I will get 54. You are now prepared to do your worksheet on convergent and divergent geometric infinite series. So here's what you need to remember. If the base on the exponent is not a number between -1 and 1, you can't find the sum. That's called divergent. If that number is less than 1 and greater than -1, you can find the sum. That's called convergent. You use this handy dandy formula to do it. You take the first term by plugging 1 in here, divided by 1 minus this common ratio, 1/3, and that'll give you the total. You are now set and ready to do the last thing we're doing on series. Have a great day. Talk to you later.